This is exercise 8B, question number 4. We're given that point A with coordinates minus 1, 4 lies on the curve. So, say I have a curve and my function of the curve is y is equal to x cubed minus 5x. And I have a point A which is minus 1, comma 4. It lies on the curve. And the curve has equation x cubed minus 5x. Point B also lies on the curve and it has the x coordinate as minus 1 plus h. This is the x coordinate of point B. Point B also lies on the curve. I know the x coordinate, but I do not know the y coordinate. Okay. Show that the gradient of the line segment. This is the line segment AB. I need to show that the gradient of the line segment is h square minus 3h minus 2. This is the first part. And I have to deduce the gradient of the curve at point A. The gradient of the curve at point A would be nothing but the derivative of the function. Let's do step by step. Let's first find the gradient of the line segment AB. When I say I want the gradient of the line segment AB, that means the gradient m is equal to y2 minus y1 over x2 minus x1. If I say my x1 is a and y1, this is x2 and this is y2, the coordinates of B. Okay, so now let's substitute, and we also know our y is equal to x cubed minus 5x. Let's try to substitute. So we have x1, we have y1, we have x2, we do not have y2. Okay, I do not have y2, so the first thing I will try to do is I need to first find y2. So my coordinates of point B, the coordinates of point B is minus 1 plus h, comma y2, and I do not know my y2. But I know my equation of the curve is y is equal to x cubed minus 5x. If in this equation I would substitute the value of x, I will get my y. So to find the coordinates of y2, in the equation of the curve, I will substitute the value of my x1. So y is equal to, in place of x cube, I will write minus 1 plus h the whole cube minus 5 into minus 1 plus h. In place of x, I'm going to substitute the x coordinate of B. So this will make it, I'm going to expand this using binomial expansion. So this is going to be a cube, that is minus 1, plus 3 x square h, okay, minus 3 x h square, or plus 3 x h square plus h cube. And now I'm going to solve this. Minus 5 into minus 1 would make it plus 5, and minus 5 into h would make it minus 5h. Okay, so now the first term I will just simplify it further. It makes it minus 1. Minus 1 square is nothing but 1. So it gives me plus 3h. Plus into minus, it's going to give me minus 3h square plus h cube. This is my second term that I had solved. Plus 5 minus 5h. I would simplify this further. -1 and +5. It is going to give me +4. Let's do the h terms. I have +3h and -5h. This is going to give me -2h. Then I have -3h square and I have plus h cube. So when I have substitute the value of x2 in the equation, I got y. So this would be the coordinate of my y2, or I would say this is my y at point B. Okay, now I have my x at point B, I have my y at point B. Now I'm looking to find the gradient of AB. So my gradient of the chord would be y2 minus y1 over x2 minus x1, where my x1 would be the coordinates of point A, that is -1, y1 is nothing but 4. My x2 would be coordinates of point B, that is -1 plus h, and my y2 would be this big equation that I have found out. What is this big equation? It is 4 minus 2h minus 3h square plus h cube. Now gradient, I will solve the numerator and denominator separately. So I'm solving it separately because it is big. So numerator is y2 minus y1, which is going to be 4 minus 2h minus 3h square plus h cube minus y1 is 4. Plus 4 and minus 4 would go away. So I am left with what? I am left with minus 2h minus 3h square plus h cube. Let's take the denominator. It is x2 minus x1. When I am solving this, so it is -1 plus h minus x1. So this would be equal to -1 plus h plus 1. So my denominator is h. So again, when I am putting the gradient function, so this would be equal to, I have found my numerator, that is -2h minus 3h square plus h cube. I found my denominator as h, and this is my gradient of the chord AB. Okay, that is my m. Now what will I do? I will factor out h. So m would be, I'll put h outside, -2 minus 3h plus h square divided by h. So my gradient is this. Let's not cancel h. Let's keep it like that. Or even if I cancel, it is fine. So this is my gradient. What is the next part of the question? They asked me, show that the gradient of the line segment AB is h square minus 3h minus 2. So I will write it in that form. So I would say gradient of line segment AB h square minus 3h minus 2. Now my B part. The B part says deduce the gradient of the curve. Okay, deduce means find the gradient of the curve at point A. Now I know that gradient of the curve at the point, at any given point, would be the derivative of the equation of the curve. So since I want to find the gradient of the curve, I know that this will be the derivative of equation of curve. Now I have y is equal to x cube minus 5x. I want to find the gradient of the curve at point A. So I would say my dy by dx at point A, the x coordinate minus 1, would be equal to, you put this on the calculator or you can even solve directly. It is 3x square minus 5. And in place of x, I'm going to put minus 1. So this is going to be 3 minus 5. That is nothing but it is minus 2. So the gradient of the curve at point A is nothing but minus 2. With this, I complete exercise 8B, question number 4 at Excel Pure Maths Year 1. Please like, subscribe, share, and ask if you want me to make videos on any other topics.